This one we have a container or a tank in the form of a cylinder. We've got a cylindrical tank here. Um, and it's leaking water out at a rate of 3 cubic feet per second. And they say that the radius of the tank is 4 feet, so we're going to draw a picture here. So we've got this cylindrical tank with a radius of 4 feet. And then it says, at what rate is the depth of the water changing at any instant during the leak? So we've got this water in the tank, right? You imagine the water in there, it's taking on that same cylindrical shape. We'll call the height of that water as it's dropping capital H, and the radius of that water is always going to be 4 feet, right? You can picture the water draining out. The radius is not going to change. All right, so identify the variables involved in the problem. We've got a volume of this thing, we've got a radius. Again, some of these variables may not be changing, and we have a height. So that's what we want to look at next. Are any of these variables constant and not changing? The radius is not changing. So when we write our equation, we'll be able to treat that as a constant. So let's look at number 3. We want to talk about what rates then would be obtained from this. So from the ones that are still changing, the volume and the height, those are going to turn into rates. So we've got the rate of change of volume with respect to time, and we also have the rate of change of height with respect to time. They tell us the rate of change of the volume is -3 cubic feet per second. And dHdt is what we're finding, and it should be in feet per second because the rate of change of a height is a linear distance. All right, so now we're going to write our geometric formula. The key here on this is to substitute any value that represents a variable that is constant throughout the problem. That radius is not changing as the water leaks out, so we're allowed to take our volume formula for the volume of a cylinder, which is area of the base times the height. I used a capital H, so let me stick with that, which means that should be capital H here. So the radius is 4 at all times of the water because it's not a cone. If it were a cone, the radius would be changing. So now our formula is 16 pi h. Now we can take the derivative of that formula and remember the only variable here now on the right side of the equal sign is h. So the derivative of v is dv dt. The derivative of 16 pi h is just 16 pi, and then by chain rule we have times dh dt. So now we're going to make our substitutions. So dv dt was -3, and dh dt we wanted to solve for. So when you solve that, dh dt should work out to be -3 over 16 pi, and that's going to be in feet per second. So that means since the rate is negative, the height of the water is changing at that rate, negative whatever that number is, 3 over 16 pi feet per second. It's decreasing at that rate, or it's getting smaller.